ओके डियर स्टूडेंट, आप लोग कैसे हैं? आई होप कि आप लोग ठीक होंगे। लास्ट लेक्चर में हम लोगों ने डिस्कस किया था अबाउट द इलेक्ट्रोस्टैटिक पोटेंशियल एंड फिजिकल सिग्निफिकेंस ऑफ इट एंड व्हाट इज द इलेक्ट्रोस्टैटिक पोटेंशियल डिफरेंस एंड so we have a clear cut understanding of what is the electrostatic potential. Today in this lecture I want to discuss with you how electrostatic potential due to a point charge can be calculated. Okay, as from the definition we know that electrostatic potential in the field of any source charge at a point is defined as the amount of work done in bringing a unit positive test charge from infinity to that point. It means if one brings a charge Q0 from infinity to a point in the electric field, then the amount of work done divided by the test charge gives you the electrostatic potential at that particular point. So, to calculate the expression for potential due to a point charge, one must have to calculate the work done in bringing the positive test charge from infinity to a particular point in the electrostatic field. So, here we have considered that Q be a source charge and around this charge there is a electrostatic field. We have considered a point A in that particular field of Q where we are interested to calculate the electric potential. The point A is at a distance R from the source charge. So in order to calculate the electric potential at point A, as from the definition, VA is nothing but we have to calculate W infinity to A and divide the test charge. Let Q0 be the test charge, which is positive and very small, and it is initially assumed at infinity. हम Q0 टेस्ट चार्ज को इनिशियली कहाँ मानते हैं? इन्फिनिटी पर मानते हैं। तो जब इन्फिनिटी पर क्यों लिया जाता है? इन्फिनिटी से लाते हैं ऐसा प्रैक्टिकली नहीं है, क्योंकि इन्फिनिटी एक ऐसा पॉइंट है जहां पर देयर इज नो इंटरेक्शन बिटवीन द टेस्ट चार्ज एंड द सोर्स चार्ज। सोर्स चार्ज और इन्फिनिटी पर अगर हम किसी टेस्ट चार्ज को रखते हैं, उन दोनों के बीच में कोई इंटरेक्शन नहीं रहता है। तो और उस पॉइंट पर इसकी इलेक्ट्रोस्टैटिक पोटेंशियल एनर्जी सिस्टम की जीरो होती है। तो निश्चित रूप से वहां से हमको लाना है, तो उस वे में हम एक कोई पॉइंट लेते हैं, सपोज दिस पॉइंट इज V एंड विच इज एट ए डिस्टेंस x फ्रॉम द सोर्स चार्ज। हम इसके पॉइंट A पर लाने के पहले हम मान लेते हैं B ए पॉइंट लाइन इन द सेम वे, ओके, विच इज एट द distance x from source charge where test charge is present. मैं मान लेता हूं या हम लोग मान लेते हैं कि Q0 टेस्ट चार्ज इन्फिनिटी से चल करके किसी एक पॉइंट B पर पहुंचा है, जहां की डिस्टेंस सोर्स चार्ज से x है। सो डेफिनेटली सिंस अगर ये सोर्स चार्ज हमारा पॉजिटिव है और ये टेस्ट चार्ज पॉजिटिव लिया ही गया है, तो क्या होगा? देयर विल बी इलेक्ट्रोस्टैटिक फोर्स ऑफ रिपल्सन बिटवीन सोर्स चार्ज एंड दैट चार्ज। ओके, सो द फोर्स, इलेक्ट्रिक फोर्स between Q and Q0 can be written as F is equal to 1 upon 4 pi epsilon 0 K Q0 upon x square. Okay, what is K here? K is the dielectric constant of the medium. Okay, as you know, air अगर है तो डायलेक्ट्रिक कांस्टेंट फॉर एयर एंड वैक्यूम के लिए एक होता है, और इसको हम चूंकि कोई भी मीडियम ले सकते हैं, तो फॉर एनी मीडियम let us assume that dielectric constant is given K, so this F comes out to be that one. And the direction of force is directed away from the point B. Okay, if test charge Q0 is displaced from B to C infinitely small displacement dx, then amount of work done will be definitely small. Since displacement is very small, so the work done will also be small. This dW can be written as equal to F dot dx. It is because, as you know, work is a dot product or scalar product of force and displacement. So here, if we put this can be written as F dx cos 180 degree. As you know, force is directed here and the displacement is here, so the direction between force and displacement is 180 degree. Angle between force and displacement is 180 degree, so that's why this can be written as equal to minus F dx. So the total work done in bringing the charge from infinity to point A. अब निश्चित रूप से टोटल वर्क की जब हम बात करें, it is the integral of dW up to limit from infinity to R, and this is nothing but minus F dx from infinity to R. If we put the value of F, we will find 1 upon 4 pi epsilon 0 K Q0 upon x square. Okay, and here is the dx. All constants taken outside, and this gives us 1 upon 4 pi epsilon 0 with negative sign as well. Q0 Q and here dx upon x square. Okay, so and limit is also from infinity to R, and this can be solved as minus 1 upon 4 pi epsilon 0. Integration of 1 upon x square dx can be written as minus 1 upon x from infinity to R, and if we take this minus sign outside, so we have positive 1 upon 4 pi epsilon 0. So we have positive 1 upon 4 pi epsilon 0, and here is the 1 upon x from infinity to R. And let me know what is the integral 1 upon x square dx, and this is nothing but integral x raised to the power minus 2 dx, and this is x raised to the power minus 2 plus 1 upon minus 2 plus 1, and this gives you x to the power minus 1 upon minus 1, and that is minus 1 upon x. And taking the limit after the integration, so we have this expression w from infinity to A, and if we calculate it, we will find that equal to 1 upon 4 pi epsilon 0 rather here k epsilon 0 k. Here upper limit 1 upon r minus 1 upon infinity. So we have w is equal to w infinite to a is nothing but 1 upon 4 pi epsilon 0 k q0 upon r. This is the work which we are interested to calculate since this has got zero value. ये उसके लिए है जिसको इंटीग्रेशन नहीं आता है, जान लें सिंस x की पावर n dx इंटीग्रेशन होता है x की पावर n plus 1 upon n plus 1, simple and you should remember it. So we have calculated the amount of work done in bringing the test charge from infinity to point A in the field. And now from the definition of electrostatic potential, now from the definition of V, the electric potential at A V which is equal to W infinite to A upon Q0. So we have 1 upon 4 pi epsilon 0 k Q upon R. Here in this expression there is no term Q0 involved. यहाँ टेस्ट चार्ज का कोई रोल नहीं है. टेस्ट चार्ज केवल वर्क डन को कैलकुलेट करने के लिए यहाँ पर लिया गया है. और V के एक्सप्रेशन में as we see here the only charge Q and R means two things are present in the expression of V. That means that the electric potential around any source charge at a point in the field will depend upon the source charge and the point where the source charge is where we are interested to calculate the electric potential. हमें किसी भी सोर्स के कारण इलेक्ट्रिक फील्ड में या किसी इलेक्ट्रिक फील्ड में किसी पॉइंट पर अगर हमें पोटेंशियल फाइंड आउट करना है तो इट विल डिपेंड अपॉन फील्ड किस चार्ज के कारण है, सोर्स चार्ज क्या है, और सेकंड थिंग उस सोर्स चार्ज से पॉइंट कितनी डिस्टेंस पर है. ये दो चीजें हैं. लेट मी रिवाइज इट एज फ्रॉम द डेफिनेशन ऑफ इलेक्ट्रिक पोटेंशियल which is defined as the amount of work done in bringing a unit positive test charge from infinite to that point. Okay. So we must have to calculate the amount of work done in bringing any positive test charge from infinite to that point. In order to calculate that one, so we have considered initially we have considered the test charge is lying at point B, which is at a distance x from the source charge along the line of path. So we have calculated the electric force between source charge and test charge, and since it is a repulsive in nature, and if we displace the Q0 test charge from point B to A is very small distance displacement dx towards C, then we must have to perform certain work against the repulsive force, and that work, which is very small, is calculated with this formula f dot dx, which is f dx. So the total work can be calculated simply by integrating this over the limit from infinite to r, and which we have calculated that much. And by the definition of electric potential, W infinite to A upon Q0 gives us the potential at point A, which we obtain is that much. Now let us explain on what factors the V depend. As from this expression, V depends on Q, which is source charge. What Q is? Source charge. And second V is proportional to 1 upon R. फील्ड के केस में हम लोगों ने देखा था कि E comes out to be due to point charge 1 upon epsilon 0, Q अपान आर स्क्वायर मीडियम में है तो निश्चित रूप से E डिपेंड Q पर तो कर ही रहा था, साथ साथ E प्रोपोर्शनल टू 1 अपान आर स्क्वायर। तो यहाँ V का R के साथ डिपेंडेंस अलग है E के रिस्पेक्ट में। इफ K इज इक्वल टू 0, अगर K इज इक्वल टू 1 मान लें, यानी फॉर एयर ऑब्लिक फ्री स्पेस, दो केस में या वैक्यूम ले लें, तो वी विल हैव B इज इक्वल टू 1 upon 4 pi epsilon 0 Q upon R. This is the expression for electric potential at a point because of any source charge are in the field. Now, how we calculate the electric potential at a particular point because of not a single point charge, because of group of charge or multiple charge which are discrete. Let us look here. Potential due to electric potential due to group of discrete charges. Okay, as we know, electric potential is a scalar quantity. So if we have to calculate the electric potential due to different point charge at a fixed point, for that we must have to take the rather vector sum, we have to take their algebraic sum. So let us assume that there are so many charges Q1, Q2, minus Q3 and Q4. If they are placed at certain distance here, let us O, and their distance from this point will be different. Let us say R1, R2, R3 and R4. Okay, so let Q1, Q2, minus Q3, minus Q4 be the charges and charges placed at distance R1, R2, R3 and R4 from point O. Then the net potential at point O will be nothing but algebraic sum of potential at point O due to all point charges, their algebraic sum. So this can be written as V1 plus V2 plus V3 plus V4, and this is nothing but 1 upon 4 pi epsilon 0 Q1 upon R1 plus 1 upon 4 pi epsilon 0 Q2 upon R2 minus 1 upon 4 pi epsilon 0 Q3 upon R3 minus 1 upon 4 pi epsilon 0 Q4 upon R4. One thing here, note always that electric potential, since it is scalar quantity, it will depend on the sign of charge. If our source charge is positive, then the electric potential at point P must always be positive. If source charge is negative, then the electric potential at point P will be negative. It means that the electric potential at a point will depend upon the nature of charge as well. Okay, similarly we can calculate the electric potential due to other system of charges like electric dipole in different situation, as we have calculated the electric field due to dipole, and this we will discuss on the next video lecture, and I think you know how the electric potential at a fixed point because of a point charge can be calculated and what is the expression comes out to be. Okay, this is all about today's lecture video. Okay, bye, goodbye.